Okay, so we are going to make our pH Flexigon, and ultimately we want it to look like this so that we can fold around and see pH, pOH, and the concentrations of OH and the hydronium ion. And this should be able to be folded in all of those directions. So you should have your pieces cut out and folded so that the lines between the hexagons fold away from you, but the triangles within each hexagon are folded up and you have a square in the middle. So what we're going to do is we're first going to take the flap that is here. We can tell that we've not finished this PO something here, so we're going to fold that to the back. And we'll notice that on this side it has, for me it's orange, you might have colored yours differently, but there's a bar of some kind there. Over here there is also a bar, and we're going to want to get those two things together. So what I'm going to do is I'm going to fold this back, but as I flip this over I want to make sure that this triangle is flipped down. Okay, so when I do that, I have the top of the OH minus here with my bar, and then I have the top of the PO here with my bar, and I'm going to tape those two pieces together. Alright, then I am going to fold the bottom up so that I can see the OH. Okay, and that's sufficient for right now. Exactly how that happens isn't real important. We'll get to the other pieces later. Okay, now on this side, works a little bit awkwardly because you can't just fold it in half. As you fold it in half, you're going to have these pieces, top and bottom, kind of sticking out. Okay, and what I'm going to notice is that if I turn this way, I have the same bar on top here and here, and I have my light colored or yellow bar on the bottom here and here. So I'm going to have to get those guys to match up. Alright, so first I just want to see how that looks. I'm going to fold that back, fold these pieces back, and they should kind of fold naturally along that line so that I can see how those line up. Alright, now I'm going to flip this whole piece over, and I'm going to slide this on top. Okay, so once I have done that, I have, for me, a green bar here, and a green bar here, a yellow bar down here, and a yellow bar down here. And if you don't have colors, this should be the bottom right corner of the bottom of the OH, and on the other side, the bottom left corner of this O plus rectangle. Okay? And then over here, this is the top right corner of the top part of the OH minus, and the top left corner of the the O plus hexagon. Okay, so now that those are lined up, I'm going to take a small piece of tape and tape those into place. Now I want to try not to catch anything else in the tape, so I'm going to have layers in between, but I don't want those layers sticking out, because if they do, they'll keep things from folding. And it is helpful to work with smaller pieces of tape. If you lose larger pieces of tape, then sometimes they go too far. So here I'm kind of taping to the back of this. I don't want to do that, so I'm going to push that so the edges line up real close, and then fold that down. Okay, so now I have my two pieces together, and if I fold this in, so I have my OH in place and I fold this in, I've got that O3 or that O plus sticking up, and I can fold in from the other side, but I've got layers that are not taped together. So I've got to really make an effort to fold over there, and I should be able to see H3O+. So let's see what's going on with the colors on the other side. So over here, it looks red to me on the camera. It looks a little bit orange, and then blue down at the bottom. So if I flip my whole thing over, I'm going to see on the other side I have those same colors, top and bottom. So I want to make sure that they line up, checking both sides, and I want to make sure that they come right to the edge so I don't get bits of paper taped where they're not supposed to be. And I'm going to tape them in place. Now notice on the back the words don't line up. That's okay. Get a little bit closer, you can see the words don't line up. That's okay, because that's the back. We only want them to line up on the front. Okay. So I'm going to tape that in place. I'm going to tape this in place. Alright, so now when I fold in, oops, I got to put it on the front side. Okay, when I fold out, I've got my OH minus, and then I should be able to flip this up and have my POH. Now at this point, I can tell I've got some things that aren't quite taped right, and so I'm going to go ahead and tape those edges. Alright, so one of them doesn't have a colored bar on it. I ran out of different colors. One of them has kind of a purple color for me. So it's the bottom of the POH, and on the top part of this, I'm sorry, that's the bottom of the OH there. Alright, and then you might want to tape where these pieces are coming together too. You don't have to, but sometimes it can help the folding work a little easier if you have those taped. Alright, so go through and move through the different faces. So you should be able to see the hydronium ion, pH, POH, and the hydroxide ion. Okay, and just make sure that things aren't coming out. Now, we know that this is supposed to be the concentration here, so what we can do is take a pen and put that in. So I'm going to make this using my square brackets into a concentration, and then I'm going to find my hydronium and do the same thing. So that's actually the concentration. Alright, and so now it's just kind of an interesting toy that you can kind of flip around and fidget with, but what we want this to do is to be useful. So we're going to look at the different relationships between these concentrations and the pH and POH. So I know that in order to find pH, I can take this number, the hydronium, and I can take negative log of that to get to the pH. So let me check which way I'm going to the pH. Here's the pH. Okay. So since in order to go to the pH, I need to flip that down, I'm going to draw an arrow pointing to the top and an arrow pointing to the bottom that says negative log of H3O+. Okay, so if I do negative log of H3O+ and I follow the direction, I get to the pH. Well, what if I wanted to go back to the concentration? So I'm going to draw some arrows going towards the inside that tell me that. And if you remember correctly, it is 10 to the negative pH gets us there. Okay. And so we can do the same thing with the other relationships. So between pH and POH, we do 14 minus each of those. So to go inside, I want 14 minus POH. And if I open that up, that tells me I get the pH. Now here I already have a direction telling me to go inside, but if I want to go to the outside, that's going to be 14 minus pH. Give myself errors. And you can switch the color that you do so that you can tell the difference between going to the inside and the outside. Now notice on this one, I have one that points up and down and one that points side to side, and that's going to be true on every case. All right. Now if I have the pOH and I want to get to the concentration of the hydronium or the hydroxide ion, then I'm going to have to go to my up and downs. And I already wrote here, so I'm going to write this one down on the bottom here. So to go in this direction, I want 10 to the negative pOH. And if I fold that, that should give me my concentration. And then to go between the concentration of hydroxide and the concentration of hydronium, going outwards, that's where I'm going to use my Kw over the concentration of hydroxide, or maybe I want to tell myself the actual number, 10 to the minus 14 divided by the concentration of hydroxide. And then that's going to get me to the concentration of hydronium. And I can do my arrow in to tell me how to reverse that process. Kw over OH. And that's what happens when I go in. And if I want to go from this concentration to pOH, that's where I have to do my arrow going to the inside, negative log of the concentration of OH. So now, when I have a question that asks me to go from one of these to the other, I find the page that has what I want. So let's say, so when I have to do a problem that has one of these, I go to the side that has what I have. So often I can calculate the concentration of hydronium pretty easily. And then I say, okay, what is the problem asking me? So if the problem is asking me for hydroxide, I'm going to go to the inside. Oops, I labeled that one wrong. I need to put H3O. Or if I want to find the pH, I'm going to follow this one and find the pH. All right,